Here we go. Let's get into it. So first up, factor the following trinomials with least coefficient does not equal 1, meaning you've got the 3 here. So we can't just go, oh, what two numbers multiply to 14 at the back and add to negative 23? I mean, there isn't anything, first off, okay? Plus, the 3 is ruining our lives. So here's how I like to factor these. I'm going to multiply 3 and 14 together. This is where you might need your calculator. Maybe you can do it in your head, a little mental math here today. What's 3 times 14? Thank you, thank you. That was a little, okay. So we have to multiply to 42 and add to negative 23 in the middle now. Anybody? I swear I'm buying flashcards. Okay, multiply to 42, add to negative 23. How about 2 and 21? But what's wrong with them? They both need negatives, thank you. So they add to the middle of negative 23. Now don't write this. This is going to probably cause me heart palpitations to put this on here. I can't just go x minus 2, x minus 21. Will that FOIL out to that original problem? No, that's why I said I can't even look at that. It's causing me anxiety. Get it out of here. So because you have that lead coefficient of 3, I'm going to scale these or divide them by 3. Now, negative 2/3, it doesn't reduce, doesn't divide to a whole number. This is what it is, right? So to put that as a factor, the denominator, the bottom, goes first, and then the numerator. Clearly, I can mentally divide negative 21 and 3, negative 7, and that's my second factor. I know some kids like to guess and check. There's a way you can do it with grouping. There's many ways to factor these. If you have something else you like, do it. I don't care, okay? As long as you can get the answer. But I'm going to do the same method just to be consistent and not make it so confusing. So same thing. I'm going to start by multiplying 3 and 12. 36. Okay, I know you got this one. What multiplies to 36 and adds to 13? 9 and 4. There we go. And of course, because our lead coefficient 3, we're going to divide these each by 3. Now 9 over 3, I can do that in my head. 3. Our second fraction, of course, doesn't divide to a whole number, doesn't reduce, it just is what it is. I would reduce it if I could, but I can't. Denominator goes first, and then the 4. Okay. Third one, same thing. I'm going to multiply 4 and negative 20. I'm going to do it above just because I'm running out of room on the side here. Okay, multiply to that, add to 11. Who's got it? Let me ask you a question. Do you know how to find the numbers in your graphing calculator in the table? I see some blank looks. Okay, let me show you. Maybe some of you know this. So if you're sitting here like, man, I have no clue what multiplies to negative 80 and adds to 11. Okay, here's what you're going to do. You're going to fire up your calculator. You're going to go to y equals. I'm going to type in negative 80. And I want to know what divides into it. So then I just say divided by x. Now, I don't care about the graph. We want the number. So I'm pulling up the table. So second graph. And then you can see, you're obviously looking at the whole numbers. I can look through there and figure out what's going to add to 11. And it's right there in front of us, negative 5 and 16. They multiply to negative 80, they add to 11. Have you seen that before, doing that on your calculator? If you're really stuck, then that's one way to go. All right, so negative 5 and 16. Then, of course, we got to divide them by 4. Now, 5 over 4 doesn't reduce. It is what it is. So the denominator goes first, then the top. 16 over 4, 4. Got it. Okay, so those are a little more time consuming because obviously the numbers you have to multiply and add to are a little bit bigger. That's probably the toughest thing we have. Now, next up, grouping. Grouping only works when you have 4 terms because what we're going to do is split it in the middle. So we have 2 groups of 2. So first thing I'm going to do is just look at these front 2 terms. So I'll worry about the back in a minute. So front 2 terms. I'm looking for a GCF. 618, they both have a 6 in them. P cubed, P squared. So now I'm going to figure out 6p squared. I need another p to get to a cubed. 6p squared times 3, 18p squared. Now I'm going to do the same thing on the back. What is the GCF in p plus 3? 1. I see some of you. 1. It's lame, but it is what it is. Now your parentheses should always match. If they don't match, something bad has happened. There's an error somewhere, you gotta fix it. They should always match, ours do. So our final answer. So one of the set of parentheses, and it doesn't matter which one, is the p plus 3, the matching. Because I really kind of think about that, it's like your greatest common factor. We're taking the p plus 3 out, and I have 6p squared plus 1 left. And of course, if you distribute that together, you FOIL it out, you'll get the original problem back. Grouping is probably not as common as the trinomials, but it does pop up here and there, okay? So I'm going to do the same thing. First two terms together. Now, only thing they have in common, of course, 2 and 7, nothing, x squared. So I'm going to need a 2 and another x and a 7. I'm going to do the back two. So this, you know, what's the GCF on 16 and 56? 8, yeah. 8 times 2 is 16, 8 times 7. We're crushing it because our parentheses match. So final answer. One set of parentheses is that 2x minus 7. And the other is the 2 GCFs, x squared and 8. All right, any questions on grouping? Okay, the last type of factoring I have for you. It's really not a new type. It's kind of a mixture of everything. So it says factor completely. So A, it's not specifically telling you what to do. Factor the trinomials, factor by perfect squares, factor GCF. You just have to look at it and know. And the fact it says completely in all caps is telling me we probably can factor more than one time on it. Happy day. Now, first thing we always look for is a GCF. I'm looking at this like, ooh, big numbers, I don't like it. Is there something that goes into 476 and 360? Yeah, I see you guys holding it up, 4. So let's pull 4 out. Now, you might need your calculator for this. 4 goes into 76, of course, 19 times. And it goes into 360. Now, like I said, the word completely is telling me I probably have to factor more than once. Lots of work. So now I just look at this trinomial inside. So I'm focused on that, which I like it because the lead coefficient on just the inside is a 1. So I have to get too carried away here. I can just play the number game. What multiplies to 90 adds to negative 19? What do we got? 10 and 9. And they're both going to need negatives. And of course, before I circle that, I'm going to put the 4 in the front. Now I'll circle it. So you just have to know what method, and you probably going to factor more than once when you see the word completely. All right, GCF. What do we got for GCF for B? 4. Must have liked 4 on this one. All right, 4 times 5. 4 times 8. Now, same thing. I'm pretty sure we probably can factor again on this very lovely trinomial. And I'm already cringing a little because I see we got the 3 for a lead coefficient. Long factoring process. Yay, yes, okay. So I'm going to multiply the outside two numbers. I'm going to think about what multiplies to negative 24 and adds to 5. Which one of those needs the negative, the 8 or the 3? The 3. And then we're going to divide them both by 3, our lead coefficient. Now, 8 over 3 doesn't simplify. If it does, I would do it. It doesn't. It is what it is. I'm going to put the bottom first, the 3, then the 8. Negative 3 over 3, I can just do that in my head. Negative 1. And then, of course, don't forget your 4 in the front. There we go. All right, last completely one, and then kind of a mixture of stuff. Okay, same spiel. Look for your GCF. 45 and 20, what's your GCF? 5. I kind of like it because there's less choice, so I think it's going to be easier. Now, same thing. We're going to look inside. I'm pretty sure we can factor this again. What do you notice about all those numbers underlined in green? Perfect. Perfect. Squares, squares. Okay, so to get 9x squared, 3x and 3x. To get a 4, of course, 2 times 2. You guys told me yesterday, plus and minus, one sign for each. And of course, don't forget your 5 in the front. Questions on that one? Okay, last thing I have for you, which is really nothing new, okay, is still a mixture. It's a random types of factoring, but ooh, so fancy. They're set equal to 0. You now need the 2 solutions for x. So you have one more extra step to do. But it's going to be the same spiel. I'm going to look for a GCF first. There isn't one. Trinomial lead coefficient 1 makes me happy. Less work. I just need to figure out what multiplies to 6, add to 5. Well, that's easy, 2 and 3, right? So here's the factoring part. What are the 2 solutions now? -2, -3. Because of course you would solve each of these, you'd have to subtract 2, subtract 3. No work needed, just write them down. Got it. All right, same spiel. I look for my GCF, there isn't one. Happy, trinomial lead coefficient 1. What multiplies to -8 adds to -7? -8 and 1. All right, 2 final answers. Of course, we'd have to add 8 over and subtract 1. All right, let me scroll it up so C is not clear at the bottom here. Again, I always look for a GCF. There isn't one. I like this one. Only 2 terms, and they're perfect squares. Perfect. So x plus 5, x minus 5. So, of course, my 2 answers, -5 and 5. Now, I don't care, of course, if you write like -5, or, you know, I have some kids that like to do plus or minus. Whatever you want to do. Doesn't matter. I'll circle both. Why not? All right, D. Always look for a GCF first. What's your GCF? X. And your 2 final answers. What's the first one? 0. Just set your GCF to 0. And what fine fraction is the second one? Yeah, you know I love a fraction. Got it. All right, any questions on that? Home stretch, then I'm going to show you some on your graphing calculator. Okay, E. GCF. No. All right, trinomial. 3. Long factoring method. Here we go. 3 times 8. What multiplies to 24 and adds to -14? 2 and 12. Positives, negatives, what do we need for signs? Got it. So that adds to your -14 in the middle. Of course, that darn lead coefficient of 3, we're going to divide each by 3. Now, 2/3 doesn't reduce, so we're just going to go with it. I'm going to put the 3 first, of course. -12 over 3, I'm going to mental math at -4. And the extra step, because we have to solve it, we're going to give our 2 solutions. So, of course, our first fraction, I'm going to add 2, divide by 3, and we'll get +4. I'm pretty sure I've taught you guys nothing new today, have I? Yeah, okay. All right, carrying on. Final 2. Then we'll do some on your calculator. I like it. 121 is a perfect square. What number squared is 121? 11. So x plus 11, x minus 11. I hardly have to factor this one. Like, I feel like I could have gone right to the answers, plus or minus 11. All right, and final one of these guys, G. Again, we always look for a GCF first. We've got it. What's your GCF on this one? Two final answers. 0 and any questions on that? Okay, last thing I want to show you, because we use our graphing calculators a lot in here. So I just want to kind of start doing some things with the calculator, okay? Just to kind of see where we're at with our skills and everything on this. So use your graphing calculator to sketch a graph of the function. Okay, nothing fancy. Fire it up in y equals. Here we go. 2x squared. Let me clear this out from earlier. I know you know how to do this. 5x. So, let's put a plus in there. Minus 2. All right, hit graph. All right, I specifically picked this graph for a couple reasons. One, the vertex of the parabola is off the screen. So I wanted to know, do you know how to change the window so you can see that? I have some confusing looks giving to me. Okay, so I'm going to show you. So I think it's obviously past -10 down there. I'm not sure how far down it is. So what I'm going to do is I'm going to hit window at the top, because this happens a lot in here where things aren't always on the screen. And I'm going to change the Y min, that's how low it goes. I'm going to change that to I'm going to wing it. I'm going to go -20. It might be longer than that. I don't know. I hit -20. I'm going to change it. I'm going to hit graph, take a look at it. Matt, let me just grab you a hard copy of the homework report. All right. Oh, now we can see it. Perfect. Okay. Now, I'm not going to get carried away here. Let's pull up the table and get a couple points and plot this thing. So second graph. Oh, all right. So I like -4, 0. Oh, man. Those are kind of off the graph. I don't love it. I'm going to start with -4, 0. What else did I have there we could use? -0, -12. I'm just going to kind of ballpark that one off the graph. This isn't going to be my best drawing here, kids. 1, -5. I got that. What was another good one? Wasn't there like a 2, 6? Yeah. Okay. So I'm just going to kind of sketch this. We're way off. That's all right. Not my best drawing. Now, the reason I had to do this is these next couple questions, but before we do those, do you now know how to go back to your graph? I hit graph, come on. And change your window back to where that's 10 by 10, the standard window. You know how to put it back to the standard window? Okay, you're gonna hit zoom at the top, and then number 6, standard. And that puts it back on our 10 by 10 window, 10 right, 10 left, 10 up, 10 down. So a lot of times we have graphs off the screen, so that's why I kind of want to start showing you this stuff today, because why not? All right, let's do this next 2 questions. These are easy. This won't be anything too stressful. Solve the following by factoring. Just did that, okay. All right, no GCF, great trinomial, a 2. Well, here we go, -24. We're going to add to 5. My lead coefficient's a 2. I feel like a broken record. Okay, 8/2, of course, 4. So there's one of my factors. 3/2 does not reduce. If it did, of course, I would reduce it. I'm just going to go with it. 2x minus 3. And of course, just like we did a bunch of them, what are your 2 answers? X equals? Okay, so here's the next question, because this is coming up in one of our next chapters. What do you notice about the solutions in relation to the graph? What is significant about -4? And if it helps, is a mixed number that's about 1.5. It's where it's hitting what? It's the x-intercepts. That's also where it hits the x-axis. So that's always a good way you can check your answers too. Look at the graph and see that it hits the x-axis at your answers. That's a really easy, quick way you can always check it. That's kind of the commonality or the link of everything together. All right, there's no graphing on your homework or anything. Like I said, I'm just kind of checking our calculator skills, working